Understanding Multimodal Data. Welcome, everyone. Before we dive into today's new topic, let's take a quick moment to recap what we've already covered. In our previous lesson, we established that the mode is simply the value that appears most frequently within a given data set. Now, when you're working through most basic textbook problems, you'll usually find just one single value that stands out with the highest frequency. It's straightforward and easy to identify. However, as we move into more complex, real-world data, things can get a bit more interesting. It is entirely possible to encounter a situation where two or more different values share that same maximum frequency. When this happens, we can't just pick one. We have to account for all of them. This brings us to our main topic for today, understanding the concept of multimodal data. Defining multimodal data. Now that we've recalled that the mode is simply the most frequent value in a set, let's look at what happens when the data gets a bit more complex. As you can see on the slide, when we encounter a data set where more than one value shares that same highest frequency, we refer to this as being multimodal. To be precise in our mathematical language, we use different terms depending on exactly how many modes we find. If a data set has exactly one mode, we call it unimodal. If there is a tie between exactly two values, we use the term bimodal. And, as a general term, if there are two or more modes present, we call the data multimodal. However, there is one special case to keep in mind. If every single value in your data set appears with the exact same frequency, for instance, if every number in your list appears only once, then we don't pick a mode at all. In that specific scenario, we say the data set has no mode. In the next slide, I'll show you a real-world example involving shoe sizes to help you visualize how this works in practice. Real-world example, shoe size survey. Now that we have defined what it means for data to be multimodal, let's move away from abstract definitions and look at a real-world scenario to see this concept in action. Imagine a teacher who wants to understand the common shoe sizes in their class, perhaps to prepare for an upcoming physical education activity. To do this, the teacher records the shoe sizes of a small group of students. Here is the raw data we have collected: 6, 7, 8, 8, 9, 10, 10, and 11. Keep this list of numbers in mind, because in the next slide, we are going to organize them into a frequency table to identify if this specific set of data is unimodal, bimodal, or perhaps has no mode at all. Step-by-step approach to determine mode. Now that we have our raw list of shoe sizes from the previous slide, we shouldn't try to find the mode just by glancing at the list, as it can get confusing with larger datasets. Instead, our first step is to organize this data into a frequency table. This makes the information much clearer. To do this, we simply go through our list and count how many times each specific shoe size appears. Let's look at our table. For a shoe size of 6, the frequency is 1. For size 7, the frequency is 1. For size 8, we see the frequency is 2. For size 9, it is 1. For a size of 10, the frequency is also 2. And finally, for size 11, the frequency is 1. By laying it out this way, we can clearly see which numbers are repeating, which will lead us directly into our next step of identifying the maximum frequency. Identifying the mode. Step 2 is to identify the maximum frequency. If you look closely at the frequency column in the table we just created, you will see that the highest number appearing there is 2. Next, in step 3, we need to identify which specific values are associated with that maximum frequency. We aren't just looking for the number 2, we are looking for the shoe sizes that appeared 2 times. Looking back at our table, we can see that the frequency of 2 occurs for 2 different shoe sizes, size 8 and size 10. Finally, in step 4, we reach our conclusion. Because we have 2 distinct values, 8 and 10, that both share this same highest frequency, we wouldn't call this data unimodal. Instead, we say this data set is bimodal. Therefore, our modes are 8 and 10. Now that we have organized our shoe sizes into a frequency table, let's move on to the final steps of our analysis. Multimodal data in grouped distributions. Now, so far, we have been looking at ungrouped data, like the individual shoe sizes we just analyzed. But let's expand our view to grouped frequency distributions. In these types of distributions, instead of looking at single numbers, we look at ranges or class intervals. In this context, we identify the modal class, which is simply the specific class interval that contains the highest frequency. Just like the example we saw with the shoe sizes, where two different sizes shared the same highest frequency, it is entirely possible for two different class intervals to share that same maximum frequency. And if that happens, we apply the same logic we learned earlier. The distribution is considered multimodal. This brings us to a very important distinction we need to make regarding the specific formulas we use for your upcoming exams. Important note for Grade X curriculum. Now, before we move on to some common pitfalls, I need to clarify an important technical point regarding grouped data. As we discussed in the previous slide, it is theoretically possible to have more than one modal class in a grouped frequency distribution. However, when we look at the specific mathematical formula used to calculate the precise mode, which is mode equals L plus the quantity f sub 1 minus f sub 0 all over 2 f sub 1 minus f sub 0 minus f sub 2 multiplied by h. You will notice that this formula is specifically designed for data sets that have a single, unique modal class. Because of this, for the purpose of this tutorial, and to stay aligned with your Grade X NCERT curriculum, we are going to focus our calculations strictly on data sets that are unimodal. This ensures that when you apply this formula, you are working within the intended mathematical framework. Common mistakes to avoid. First, a very frequent error is confusing the frequency with the mode itself. It is easy to look at our frequency table from the shoe size example and mistakenly state that the mode is 2. But remember, 2 is simply how many times the sizes appeared. The mode is the actual value, in this case, the shoe sizes 8 and 10. Always ask yourself, am I naming the item, or am I naming how many times it appeared? Second, do not fall into the trap of assuming there must always be only one mode. When I first started learning statistics, I often felt the urge to fix the data by averaging the two high-frequency values together to get a single number. Please avoid this. If two different values tie for the highest frequency, as we saw with sizes 8 and 10, you must acknowledge both. They are both modes. Finally, be careful not to identify a mode when all frequencies are equal. If you encounter a data set where every single value appears exactly once, or if every value appears the same number of times, you cannot simply pick a random number and call it the mode. In such a scenario, the correct mathematical conclusion is that the data set has no mode at all. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even students who understand the concept of the mode can sometimes fall into these traps, so please pay close attention to these 3 points. Keep these distinctions in mind as we move into our final summary of the key takeaways. Key takeaways. All right, we have reached the end of our lesson. Let's quickly recap the key takeaways to ensure everything we've discussed today is clear. First and foremost, always remember that the mode is not the frequency itself, but rather the specific value or observation that carries the maximum frequency in your data set. Next, let's review our terminology for different types of distributions. If a data set has exactly one mode, we call it unimodal. If there are exactly 2 modes, it is bimodal. And if you encounter 2 or more values sharing that same highest frequency, we use the general term multimodal. It is also crucial to remember the special case we discussed. If every single value in your data set appears with the exact same frequency, meaning no value stands out as more frequent than the others, then we say the data set has no mode at all. Finally, when we move into grouped frequency distributions, our first step is always to identify the modal class, which is the interval with the highest frequency. However, as we noted earlier when looking at our calculation formula, for your current curriculum and our upcoming problems, we will primarily focus on distributions that are unimodal, meaning they have a single, clear modal class. Keep these points in mind as you practice, and you'll avoid the common pitfalls we covered earlier. Great job today!